Hey everyone, in this video we will understand what is the meaning of design and analysis of algorithms. So I hope you have heard this term that we have to design the algorithm, we have to do analysis of algorithm. Okay, so what is the meaning of design and analysis of algorithm, and why not analysis and design of algorithm? Okay, why not the opposite thing? So let's understand. In the previous video we have already understood what is algorithm. So we understood that if we are given a problem or a question, okay, for which we have to write the algorithm, it means we have to write the various steps or the logic for that particular problem which can actually solve that problem, okay. And the problem can be any computational problem, like finding the number out of the various number, okay, finding the factorial of a number, okay, or you can say some any other computational problem. So we write the algorithm and we use the various data structure. We can use the array, linked list, okay, or any of the other data structure to solve that particular problem, okay. And we write the algorithm normally on the piece of paper, okay. And to implement the algorithm, we write the program which can actually take the input and which can actually generate the output. And we can implement the you can say algorithm in the programming languages like C, C++, or any of the other language that we know, okay. So basically, when someone says that you have to write the algorithm for a problem, that means we have to design the algorithm, okay. That means we have to design the various steps, or we have to write the various steps which can actually solve that particular problem, okay. So writing the algorithm means designing the algorithm, okay. Now, what do you mean by analysis of algorithm? Okay, so let's understand. Let's say you are given a question that you are given a sorted array, okay, and you have to check whether a particular element is present in that array or not. So sorted array means all the elements are in some sorted manner. For example, the elements can be in increasing order or they can be in the decreasing order. So here all the elements in the array are in the increasing order, like 5, 8 is greater than 5, 10 is greater than 8, and so on. And let's say you just say, I want to search a particular element, let's say 30. I want to know whether 30 is present in this array or not, okay. So this is the question. Now, to solve this problem, what can be the algorithm or the various steps or the approach or the logic to solve this question? So one simpler way to solve this question is you can apply the linear search. So if you don't know what is linear search, I will make a separate video to make you understand about this linear search with the help of code also, okay. But for the time being, let's understand in simpler manner what is linear search. So linear search means, let's say these are the numbers, okay, and you want to search a particular number. So the simpler way is like you check your number with each of the array element one by one, okay. That means you check whether 30 is equal to 50, okay, then whether 30 is equal to 8, then whether 30 is equal to 10, and so on, okay, till you are done with all the elements. Or if you are able to find the element, let's say in like before the end of this array, then you will stop there. Otherwise you will keep on checking each and every element till you find your element or the array is completed, okay. So this is like linear search, searching the element in a linear fashion one by one, okay. So if you find the 30, okay, in this way, then how many you can say comparisons will be done? So first you will compare 30 with 5, okay, this is not equal. Then 30 with 8, 30 is again not equal to 8, 30 is not equal to 10, so on, okay. So when you will come here, you will say 30 is equal to 30, yes, and you will stop here. So you did how many comparison? 1, 2, 3, 4, 5, 6, 7, 8, okay, and then 9th comparison. So after 9 comparison, okay, you were able to know that 30 is present, okay. And if you want to find 32, then you have to do 10 comparison, right? So for this array which contains 10 element, you are doing 10 comparisons to know whether your element is present in the array or not, right? Now let's say this array size, okay, which is denoted by, let's say n, it is very large. Let's say 10 to the power 9, okay. That means 10 to the power 9 is 1 billion, okay. So let's say if array contains 1 billion numbers, then how many maximum comparison you have to do, okay. So let's say if the element is at the last, okay, so for n equal to 10, okay, this array size is 10, then you have to do 10 comparison. So in the same way, if the array is of size 10 to the power 9, that is 1 billion numbers. So if the element is existing at the last, okay, then you have to do this number of comparison, 10 to the power 9 comparison, and then you will be able to know whether your number is present in the array or not. And this is very large number of comparison you have to do, okay. It will take a lot of time to search your number using the linear search, okay. So if you give this solution in the interview, your interviewer will not be happy, okay, with your approach. He will then say, okay, tell me the another approach that you know or that you can apply to search your number in this array in lesser number of steps, okay. Lesser number of comparison should be done, and you should be able to give this answer whether your number is present in the array or not, okay. I'm not happy with this linear search. Then you start thinking of some another approach, okay. Then you think of another approach. Then you remember a game that you played in your childhood. What was the game? So your friend say to you that I will actually think about a number in my mind, okay, and I will not tell you what is that number, but I will tell you that the number is between, let's say, 1 to 10, okay. I will think any of the number between 1 to 10, okay, and you have to tell what is that number, okay. And you can ask some questions from the John, okay. John will never tell that what is the exact number, okay. He can just answer in the yes and no fashion. And what will be the question that you can ask, okay. So let's say John think of a number, okay, let's say it is 9, okay. Now you have to tell what is the number that John has thought in his mind, okay. Now you know the range, that is number range is 1 to 10, and the number that John has thought, it will be between 1 to 10 only. So now with this knowledge, what you do, you find the mid of the 1 and 10, that is middle of the 1 and 10. So what is the middle of the 1 and 10? 1 and 10 is like 1 plus 10 by 2. This is the way we can find the mid number, okay. 1 and 10 is 11, 11 by 2 is 5, okay. So 5 is, you can say, middle number between 1 and 10, okay. Then you ask a question to the John whether the number is 5. John will say no, okay. And then you ask whether the number that you have thought, it is smaller than 5 or greater than 5. So John will say yes, the number is greater than 5, okay. Then you know that as number is greater than 5 and this part is lesser than 5 and this part will be greater than 5, so your number can lie between now 6 to 10, okay. 5 is not the number, so number will be lying on this side, 6 to 10. So what you do, now you find the mid number between 6 and 10, okay. So it will be 8, okay. Now you say, okay John, the number is 8 or not? John say no. Then you ask whether number is greater than you can say 8 or smaller. John say it is greater because 9 is greater, okay. So then you think, okay, number is not 8, it is greater than 8, so number can be between 9 and 10, okay. Now you find the midpoint of 9 and 10, okay. So the midpoint again will be 9, okay. Now you ask the John whether number is 9. John will say yes, okay, that I have thought number equal to 9, okay. So you see that to search 9, how many times you have asked the question to the John, okay. So you first find the midpoint 5, then you ask one question, then you find the midpoint of 6 and 10, that is 8, then you ask the question, then you find the midpoint of 9 and 10, and at this point you ask the third question, and in third attempt you are able to know what is the number, right? But if you are given this array and you have to search this 9 using the linear search, then how many times you have to compare your element with all these elements? Total 9 times, okay. So linear search will search the numbers in 9 comparisons, but with the help of this approach that you played with the John, you are able to find the answer in 3 comparisons or 3 questions. So obviously the game that you played with John, it is better in finding the or searching the element out of large number. So let's say if you are having 10 to the power 9 elements, okay, in this array and they are in the sorted manner, then yeah, you will be able to easily find the number in lesser number of comparison. So basically you have actually played a game which is actually based on a technique that is known as binary search, okay. So I hope many of you know what is binary search. If you don't know, I will make a separate video on binary search, okay. So this actually technique of again finding the midpoint between the range, okay, and then again finding the midpoint repeatedly is actually one way of searching the number in a sorted array. And in this question you were given a sorted array, right? you are not given an unsorted array, you are given a sorted array. So binary search, this technique can very well be applied on the sorted array, okay, not on the unsorted array. So basically, if you are given a sorted array, then you can analyze your linear search algorithm and you can very well give the answer that yes, binary search can be applied, okay, and that will be the efficient algorithm. Efficient means that it will take lesser time to give the answer, okay, using the binary search. Okay, it will take many number of steps, it will take lesser number of steps, okay, to give the output. So this is like analysis of algorithm. So basically, when someone asks you a problem, you write the algorithm, then before writing the program, you actually analyze that algorithm. Analyzing means you observe the complexity of that algorithm with respect to time and space. So basically, in the previous question, we saw that in linear search, it will take a lot of time to search a number, okay, in a sorted array. But if we apply the binary search, it will take very less time, okay, to find the number in the, you can say, array, okay. So basically, if you are familiar with linear search and binary search take n times, okay, or you can say n steps to search a number in the worst case, okay. Maximum number of comparison you will have to do n, okay, but in binary search you will have to do only this number of comparison, log n comparisons, okay. So if n is 10 power 9, then in linear search you have to maximally do 10 power 9 comparison, but in binary search you will have to do lesser comparison. So if n equal to 10 power 9, then if we place n value as 10 power 9 and base is 10, then this 9 will come here. So you have to do only 9 comparison in a array which contains 1 billion numbers if you apply the binary search. And here in linear search, you have to do 10 power 9 comparison. So obviously, this is very much better on the sorted array, right? So you saw, okay, that binary search is taking lesser time. So this type of observation is called analysis of algorithm. You are analyzing whether your algorithm is better in terms of giving the answer in lesser time, okay. And I will tell you space also in the next video, okay, that how much main memory space is your algorithm or approach is taking. So on the basis of these two factors, okay, we will actually analyze our algorithm in this course also, okay. So after analyzing your existing algorithm, that's a linear search, you again revise your algorithm and you devise a technique or a new technique called binary search, okay, and then again you analyze, okay, what is the time complexity, okay, of that particular algorithm that you have devised, let's say binary search, and you saw, okay, log n and log n is very much lesser than n, okay. So this type of analysis, you can say, you have to do on your algorithm, and this is called analysis, okay. So first you design the algorithm and then you do the analysis of your approach, whether your approach is good or not with respect to your time and space, and after some analysis you write the program, okay. So this is the main thing that you have to do in this course, that you have to again and again analyze your algorithm, okay. Do not just write the algorithm, okay, whatever comes to your mind and you just program, okay. Then the objective of this course is not going to be fulfilled, okay. If you are understanding DSA, that is data structure and algorithm, and if you want to go for the interviews for Amazon, Microsoft, Google, and any of the other good company who ask you actually a good question on the data structure and algorithm, then you must analyze your algorithm, okay, so that you can reach to a better solution for a given problem, okay. So this was actually design and analysis of algorithm, and the question was, and one of the question that I asked initially was, why can't we say analyze and then design your algorithm? So basically, at the first step we design the algorithm and then we analyze, okay. At the first step we do not analyze actually, okay. We have to first write something on the piece of paper, okay, then only we can analyze. So that is meant by we first design and then analyze. So yeah, I hope you have understood what is the meaning of this design and analysis of algorithm. So if you have any question, please write down into the comment box, and please like, comment, share this video. So let's see in the next video, what are the various characteristics of a good algorithm, okay. So till then, goodbye.